Okay, hello everyone. So yes, as I was introduced, I'm Fillip Rakowski, I'm co-founder of VStorefront, and today I want to talk a little bit about, is this working? Nice. So today I want to talk a little bit about optimizing JavaScript applications. Do we have any JavaScript developers in here? Please? Oof. Okay. Okay, so we can omit this part. And if any of you doesn't know what VStorefront is, this is actually a headless progressive web application for e-commerce. So if you know PWA Studio, you probably know PWA Studio because there is actually no other topic than PWA right now. VStorefront is kind of PWA Studio, but on Vue.js, and this is also backend agnostic. So on all these headless solutions, you can like pick what you want. So you can pick Magento for e-commerce, you can pick WordPress for CMS content. You can pick Klarna for payments. If you don't like WordPress, you can put Prismic. Actually, this is how it works. We are also like the probably most popular open PWA for e-commerce. We have more than 20 live implementations. And actually, one of the things that we are advertising most is the fact that we are really fast and we have really good performance. And today, I would like to share with you actually what techniques we use to achieve this great performance. So first of all, is there anyone here who thinks performance is not important? Okay, so we have one person. So I'll try to convince this one person. So first of all, what we need to be aware of is that actually 1 second is enough for the user to do mental context switch, which means they will actually think about something else and probably do something else. For example, like my girlfriend would probably watch images of funny cats. Some other people would check their Twitter feeds. So optimizing performance can also do a lot of good to your business. It doesn't, if the previous image haven't convinced you, I will show you some stats because like everything proven by numbers is wisdom. So 2 seconds actually optimization in load time reduction resulted in 15% more downloads for Firefox. So if you think that choosing a browser is actually a matter of what we think is best, it doesn't necessarily is. It's also a matter of good user experience. So even if you have some preferences, bad performance can impact those preferences. 1 second slow that resulted in 11% less page views for a birding group. So as we have seen, people got distracted. They started watching funny cat images. 2 second delay resulted in a 4% loss in revenue per visitor and 4% reduction in clicks for Bing. So for Bing, it was a lot of money. And this is interesting, cutting page load time half resulted in 13% increase in sales. So we have like direct connection between sales and between speed. So we can actually say that speed equals money. So we like earning money because actually this is why we are making business. So let's see what impacts actually up performance and how we can make more of this money. So when user enters our website, the first thing that happens is that he or she is making a request. He's making a request to the server, and the server actually responds with some data, with some JavaScript files, with some HTML files. Then those files need to be parsed. Then those files need to be executed. Then once we have this, we are rendering the view, so the part that user sees. And rendering is usually not the bottleneck in most of the application. There are some rare cases where it is. But usually the problem is in the first two. And the thing that influences the first two most is bundle size. So how our bundle size grows over time, why it becomes so big that it becomes a performance problem. So let's say we are creating an application. Here is an example in Vue.js, and actually we are starting like this. So we have our main.js, we have our library in Vue.js, and we have main root component. After some time, we are adding route. For example, our first route homepage. After some time, we are adding product page, maybe some third-party library, and slowly, you are adding more and more things, and our bundle starts looking like this. So actually, every new module, every new feature that we will add means bigger bundle. And when we know that speed equals money, then does it mean that more feature means less money? Actually, yes and no, because performance is all about trade-offs. So sometimes some feature is so useful that it's worth this performance impact that we'll make. Sometimes it's not. But before we run into trade-offs, let's see what we can do actually to make this bundle smaller. So first of all, usually when we are building something, we're using tons of third-party libraries. So choose your third-party libraries carefully. And there's a great website that actually lets you do this. It's called Bundlephobia. And on Bundlephobia, you can actually find any NPM package. For example, if you're using view carousel or we are actually using any slider, you can see what would be the impact of this package on performance. And what is even more important, we can see similar packages and see how much are they better or how much worse they are in terms of performance. It's also very good if, for example, we are encountering some library that is not fulfilling all our needs, so we can see the alternatives. OK, this is pretty obvious, but let's dig a little bit deeper, how to optimize the bundle size. And to dig a little bit deeper, we actually need to know how this bundle is created. So how Webpack bundling works, because in most of the modern applications, we are using Webpack to bundle our files. And actually, Webpack under the hood is creating something called dependency graph. So usually, in the application, we are specifying something called entry point. And Webpack is going to this entry point, checking all the imports, adding them to the graph. Then on these files, adding those imports to the graph, et cetera, et cetera. Then we have all the file tree. And all of this is actually bundled into one file. If you didn't get it, this is like how it looks more or less visually. So this is our entry point. Then in this entry point, we're importing 4 files. So Webpack is going here. Then Webpack is going to the imports in all of those files. So actually, in here only to router. And adding this to the dependency graph. Then only product has imports. So we're adding Clodash, and voila, we have our bundle. Let's call it app.js. And what's the problem with this? The problem with this is we might not need some of those. For example, if you are in a home page, we certainly don't need the product page code. And when we are in a product page code, we certainly don't need home page code. And you can imagine if you have like 100 routes, then you usually don't need 99% of your application. So instead of having one big JavaScript bundle, you can actually split it into smaller bundles and download only the thing that you need. And you can use code splitting and lazy loading to do this. And code splitting is actually like splitting your code into multiple files instead of one. And lazy loading is loading those chunks, those small parts, on demand. So on the initial load of your web application, you're only downloading what is needed. And then, for example, after some interaction, like moving to the next route, we are downloading the next parts that are needed for this. And syntax actually for lazy loading is very, very simple. If you're using Webpack, at the top we have regular import, which is just import something from something. And if we want to load something lazily, then we need to wrap it in a function, because the import statement will be evaluated only when this function will run. And by doing this, we're actually, Webpack under the hood is creating 2 bundles, so we have 2 files. And if you're working with Vue.js, then it's equally simple because we have single file components, and it works the same as every other JavaScript module. If we are working with React, you can use React Lazy, lazy load components. Then we can use, for example, React Suspense to give a nice waiting experience and some errors. So knowing this, now we can actually, if we're using Vue, split our routing and make every route loaded lazily. And this is what we did with ViewServer, the first thing when we were optimizing it. And we were able to optimize it like by 40%. And it it can take you 3 minutes. So this is one single technique that can really do the job. So the output will be more or less like this. So we'll have 3 files. When we enter the website, we download main.js. And when we're encountering homepage, we are downloading main.js and home.js. When we're encountering a product page, we are downloading main.js and product.js, etc. OK, so I said previously that code splitting is actually splitting the parts of the code that we don't need on the initial download. So you may think, what else we don't need? So we certainly don't need other routes, but we also don't need the things that we don't see. And those things are modals, those things are sidebars, and sometimes some things below the fold. OK. There is one thing about lazy loading. It can impact your UX in a negative way. Why, you're asking? So all those buys that we are actually deferring are not going to magically disappear. So if someone will click on something that should trigger this modal, then they are downloading it. And depending on your network connectivity, sometimes it can take even a few seconds. So imagine someone approaching your website, clicking or, I don't know, log in, then waiting 1, 2, 3, 4 seconds, nothing happens. People can actually leave your website. People can get annoyed. They can perceive it slow. This is a really bad user experience. So to solve this problem, we should use prefetching, which is actually downloading assets before they are actually needed. So the cool thing about prefetching is it works only when browser is on idle, so it's not affecting your performance at all. So at the beginning, we are downloading only what we're needing. And when browser is not doing anything meaningful, then on the background, it's downloading all the other files. So when we click on a modal, it's already downloaded. And how to do this? There are many ways, but going case by case, we can actually use something called magic comments in Webpack. And those magic comments are just comments before the import statement. And this, on the runtime, will transfer to something called resource hint. So this is actually a native API, native HTML API. OK, so we are pretty good with dealing with our bundle size, with cutting things. But we're not dealing very good with the things that we already have. So let's say we downloaded HTML file, the main HTML file. And on the next visit to this website, we need to download it again. And this is just a waste of performance. So there is a thing called Serviceworker, which actually acts as a proxy between your client application and network. And because it works like a proxy, it can, for example, check the cache and see, OK, I already have this file, so I want this file to be served from the cache, to be served instantly. And this works really good, because we can even use it for offline usage. And this is actually how offline mode works in every progressive web application. In progressive web applications, you're caching so-called app shell. Sometimes you're also caching other assets, and it's served directly from the cache. So user perceives this as instant. This is really good because they immediately see something on the screen, and then in the background, we are downloading the rest. For example, the data, repopulating the view with the data. But if user actually sees something, they can focus on this and just wait for this data, no matter how bad the network connectivity is. And if we are using service workers and maybe Workbox plugin or something else, we will see on application tab which files are actually cached and which will be served from the cache. OK, who knows what's the biggest problem of single-page applications in terms of performance? I suspected this. So single-page application require JavaScript to be executed before user sees anything. And this is a really waste of time, because when we are approaching a website which is written purely in JavaScript, then we are downloading HTML file, which is actually empty, only have a link to the JavaScript. So it needs to be downloaded. Then JavaScript is parsed, JavaScript is executed, and then page is rendered. But before this, actually, user sees white screen, sees nothing. So this is a really bad user experience. And to solve this, we have something called server-side rendering. Server-side rendering, as name suggests, is rendering site on the server. And now the process looks more or less like this. So page is rendered on the server. then we are sending this pre-rendered HTML to the user, so they actually have everything on this web page. It's not a blank white web page. Then JavaScript is parsed and executed, and then this JavaScript is taking care of this HTML to make it interactive. So at the beginning, user is getting not interactive website, but at least they're getting something. So it's much, much better user experience. There's one problem with server-side rendering, depending on your framework, but we struggled with the thing that actually on Vue.js, when you have initial state of the application on the server, it's added to this HTML. So you have huge, huge, huge object representing all the state of the current page. For example, if a category page, it can be really huge. In our case, it was a little bit smaller than 1 megabyte. So this is really huge thing to download, and this can impact your performance in a really, really bad way because, again, it's huge. So what we need to do, actually, is on the server side, render this page and then filter this initial data to only fields that are needed, or you can even defer hydrating, so-called hydrating, so taking control of the website by JavaScript and call the server and get this data again. There are many strategies, but basically the bare minimum is filtering this data on the server side. Okay. Also, the one thing that is really, really important in terms of performance is loading images lazily, because those are usually very big assets and they're taking a lot of time to be downloaded. So we should only download images that are visible in a viewport. This is also what we are doing in ViewStorefront. So we have a placeholder, and when this image is in a viewport, then we are downloading these images. So by doing this, we are really lowering the number of the network requests. Also, with so-called source sets for images. Source set is actually a set of sources for one image, and different sources are for different resolutions, for different devices. So it's obvious that on desktop, we want image with a much better resolution than on mobile. We don't see the difference between slightly worse resolution and the initial image on mobile. So why don't we download just smaller images? So use also sources. So those are the things that we are constantly doing in ViewStorefront to improve it. This is a really high-level overview because you need to do a lot of small tasks, actually, a lot of groundwork when you care about performance. But it's also important to measure this. And it's also because if you don't measure it, we don't see actually if there was any improvement. And it's also important just to identify stuff. So how we do this? So the first thing I would suggest is using DevTools coverage tool. If you will actually click Command-Shift-P and type coverage, you will see this. And then you can run this on any website, and the red bar will show you actually how much of the code wasn't executed. So this is actually the part that could be lazy loaded or could be even removed from your website. This is, by the way, Vue.js.org, so they have certainly room for optimization. The second thing I would suggest, once we know how many things we should optimize, is Webpack Bundle Analyzer. So this is actually a tool that visually shows you your bundle and how much place actually modules are taking there. So as we can see here, for example, we have two files, common.js and bundle.js, and then visually we see how many each library is taking out there. Installation of this is very, very easy. We just need to actually require this plugin in our Webpack config and register this. And that's all. When we type yarn build or npm build, then we actually see Webpack Bundle Analyzer on one of the Chrome cards. Also, we should think about something called performance budget. Performance budget is actually, okay, we are saying that we don't want our files to exceed this size. This is our performance budget. This is actually the size that we're operating in. And there is a very nice package called bundle size. And you can install this. You can define the files and their sizes that are maximum. And if this file is exceeded, the bundle size package will yell on the console. It has also very nice GitHub integration, so I really, really recommend this. And to just see how many things we are importing while coding, there is import cost plugin. So we can see if you're not accidentally importing something that is 1 GB. And this is like optimization during the coding, just to know what's happening. Also, the important thing is, even if we'll optimize everything perfectly, user will eventually still need to wait. So we need to deliver proper waiting experience, and actually delivering proper waiting experience, at least in my perspective, is also part of optimization. And actually, it's not very hard because we need to show user something. Usually, this is so-called skeleton, so we're more or less showing what kind of interface they can see once it's downloaded. This is another example, and that would be everything from me. I hope you learned something from this presentation, and thank you. Do we have any questions? Mm-hmm. Jesus, I'm gonna come to you. Mm-hmm. I think so. Yes, why not?
That's something you guys
we have Redis, but
okay, but some
yes, it's certainly worth doing.
Fantastic.
No questions. Okay.
More questions? Anyone? We got time, a couple minutes. All right. Well, thank you, Philip.
Thank you.